Good morning, everyone. So, yes, I work for the World Wide Web Consortium. I'm based actually in Boston, and one of the groups I'm involved in directly is a Web Performance Working Group. It's a nice little group within W3C, and we have basically a goal of giving you data and APIs to make your job easier, to make your web application running faster. That's what we've been doing since 2010. So I'm going to give you a little update of what we did for the past, I would say, 10 months. But just before I get to that, one thing is things that we did in the past prior to that. So if you're familiar, we've been working on the navigation timing specification. So it tells you, give you all kind of data on how fast your page is going to load. We're wrapping up the work on resource timing, where we give you the same information, but this time for every single resource available on your page, including XHR calls, by the way, and CSS images, for example, like background images. User timing is done pretty much at this time. It's giving you the possibility to time your applications with managing your own timestamps. So those were timing related. And in the other category of APIs, we've been working on APIs to save power, energy, especially for mobile phones, for example, and also saving CPUs as well. One of them is a page visibility API, a very simple one which tells you only one information, which is the page visible to the user or not, so that you don't have to run applications when basically the page is not visible to the user. Another one is request animation frame that all of you ought to be familiar with if you're doing JavaScript animation. Request animation frame allow you to basically do those animations without going overboard on how fast you have to actually run the JavaScript loop so that you can spare the CPU like that. It's going as fast as the screen is able to display it. And a small one we did was the high resolution time, which gives you basically some milliseconds timing information. All of those have been implemented more or less. As I said, we're finishing the work on resource timing. Of course, for some of them, you do have to use the latest version of the web browsers to be able to use them. So you may have to use patience if you still have to deal with old ones. So what's next? So most of those, you will not be able to use them at all in web browsers. Including tomorrow, you probably have to wait until mid-next year to be able to see some of that. And I'm going to go through some of those. Some of them are just ideas. We didn't even start working on them. Some of them are pretty advanced. So the first one is navigation timing 2. Navigation timing 2, again, extending what we built on. I think the most interesting information here, besides the fact that we are now giving you timing in some milliseconds, is the fact that we have the timing information for link negotiation, so that you know how long it takes to actually wake up the network in your application, if you have to. Prerender is something which has been implemented in one of the browsers out there and being deployed in another one. It's pretty simple. If you're familiar with prefetch with HTML5, when you can basically prefetch a resource so that when the user clicks on it to go next, he will get the page faster. This one will not only prefetch a resource, but also pre-render it inside the browser, so that as soon as the user clicks on the next link, he will get the page right away. Of course, you do have to know which page is going to be clicked by the user to make that super efficient. And it does a toll on your network. Speaking of toll on the network, resource priorities is probably the most interesting one that people should look into right now. So we are addressing, one of the things that we want to do is to give you the possibility to indicate to the user agent which resource to load first and which resource to load last. Right now, it's mainly based on document order. So if an image appears first in the document, it's going to be downloaded before the next image, and so on. The only exception to that is for script. which with HTML5 giving you some options, and I'll come back to that. We are currently working on two ideas. One is lazy load, and the other one is postpone. And we're going to publish the first public working draft for that this week. But the editor's draft is available on the web as well. So the first one is lazy load, and that's based on network. And basically, if the network is too busy, the download of the fetch of the resource is going to be delayed until the network is available for it. And the second one, postpone, is based on the visibility. If the bounding box of the element is visible, then the resource will be downloaded, and if not, it's not. And we have a counterpart in CSS as well. One thing that I thought would be useful would be to tell you, so we already have defer and async with HTML5 that you should be familiar as well. And I made you a little slide to give you how it basically interact. So of course, postpone, which is based on element visibility, does not apply to script. Only lazy load applies to script. So if you basically put a lazy load and an async attribute, you're not only doing an asynchronous load of the resource, meaning you're not waiting for the resource to be there in order to actually execute the code right away, but you're also waiting for all on the non-lazy load resources before going and fetching the resource as well. So that's one of the idea. And basically, defer does defer and lazy load has no effect when you actually defer the script. And again, one of the things that we need to clarify in the spec is that the document order is being preserved. Another idea is beacon. So the use case was we want to be able to send a lot of data, especially analytics data, back to the server. And of course, because it's analytic data, we want to do it as last as possible so we can get all the data. But the problem with that is if you try to wait as long as possible and you try to do, for example, an XML HTTP request back to the server on the unload event of your document, you cannot do that asynchronously, therefore leading to frustration with the users. So beacon was basically says, here is a bunch of data, send it back to the server whenever you can. It's under the responsibility of the user agent. And so it's a one method, pretty simple, simplistic API. And again, we have to refine it. For example, what does it mean to be under the responsibility of the user agent? What kind of guarantees do you have? For example, if the user agent crashes. Error log was something we talked about during the workshop we had last year. And basically, a lot of the time, when people are exiting your website and unable to access it for whatever reason, you don't know about it because you're not on the website. It could be because there is no network, or there is network troubles, or it's simply because you misconfigured one of your proxy down the line, and again, the user cannot access your website. And you have no way to know that. So error logging will log those errors so that for you, if you activate it, and will basically later on give you access to them once the user can get back on your website. So you know how much failures they encountered before they were able to access your website. JavaScript Preflight Injection. That's an even far-fetched idea. I think we still need a lot of work if it is going to actually make it. But basically, the use case is you have a web application that you do not control, and you still want to do monitoring over it. From the client-side point of view. So you want to add your own script to it. But if you do that, you may mess up the web application itself. And it may not work at all just because you added this script. So CDNs like Akamai do that very often, but they don't want to mess up your web application. So they're looking for ways to basically insert script without touching the page itself. And right now, the idea is to have this pre-flight cookie. But I think it's going to require a lot of thinking before we get to something there. Finally, display paint and asynchronous scrolling. Those are point of pain that developers are suffering today with performance. How fast am I able to paint on the screen, and how fast can you scroll through your applications? And at the moment, we know there is a problem. We don't have an idea yet on how to resolve it. I'm hoping that by the end of the year, we're going to be able to actually get some a bit more concrete ideas on those. So all of that to say, if you have ideas or if you have feedbacks, please don't hesitate to contact us. We have a public mailing list, and we are, of course, on the web. Thank you.